Hi, hello, namaskara. Welcome back to Diksha Karnataka once again with another mock test uh, solutions and analysis. So this time we are going to do mock test 3. So I hope you people would have loved the mock test 2 as well as mock test 1 and the corresponding paper discussions and all the solutions that we have done. So if you really like them, please do press the like button, and also for more and more such content from our side, kindly subscribe to our channel, and also for timely notifications press the bell icon as well. And right as all of you were wanting this particular mock test to attempt the question paper, quickly join our WhatsApp channel. The link is given in the description box. And also for those people who want to keep away from the social media distraction and do it at your own kind of focus level, so we have a separate dedicated portal created just for you, which also the link is attached in the description box. So you can go there, register yourself, and get the question paper PDF directly into your personal email ID. So how cool is that, right? So that you can just attempt the question paper without any kind of distraction, just focus into it, right? And this is going to help a lot of students, so please don't forget to share our videos to the rightful people. All right, so let's get on to the business. So physics paper discussion part 1. Once again, like every videos we do it part by part. So first part, first 30 questions, question number 121 to 150. Let's see the first question, shall we? Okay, so the first question: the maximum and minimum distances of comet from the sun is 8 into 10 to the power 12 meters and 1.6 into 10 to the power 12. So it's something revolving around the sun. So if the velocity at the nearest is 60 meter per second, what will be the velocity in meter per second when it's the farthest? So this is a basic, very simple question where you are being tested of the conservation of angular momentum. What is angular momentum formula? Angular momentum formula, or even if you just take the mass away from it, in the angular momentum, mvr is constant. Okay, m1 v1 r1 is equal to m2 v2 r2. So m is constant, so let away that. So we can write simply using the velocity of the near, okay, into distance of the near is equal to velocity of the farthest point into distance of the farthest point. Now let's fill in all the details. So the nearest point, we have velocity that is shortest nearest to sun, it is 60 into 1.6 into 10 to the power 12 is equal to velocity at the farthest point into the farthest distance is 8 into 10 to the power 12. Okay, so it's a very simple calculation. It's 5 and 60 goes 12, and the final answer is option C, 12. Okay, such a simple question, right? So you just have to keep in mind the conservation of angular momentum, and for the same object, the product of the distance and velocity will be constant throughout the revolution. So at the product of distance and velocity at farthest point equals to nearest point, and then cancel out the similar terms and you will get the answer. All right, it's a very simple question. Okay, so I hope all of you have got this. Let's go to the next question, shall we? Yes, a steel cable with a radius 2 centimeters supports a chairlift, okay, like a chair car, cable car, like that sort. Okay, at a ski area, okay, wherever you ski, if the maximum stress is not to exceed 10 to the power 8 Newton per meter square, what is the maximum load the cable can support? Very simple. Once again, you are being directly tested of the stress expression, which is a load by area, right? So all of you know the load, the stress is already given. Maximum stress possible is 10 to the power 8, I'm sorry, plus 8. Load is unknown, and the area is 2 centimeter is the radius, right? So the area of the cross section will be pi into 2 into 10 to the power minus 2 whole square. It's in centimeters, so don't forget to convert it to the meters. Okay, so 2 into 10 to the power minus 2 whole square. All right, now just load is very simple, cross multiply. So load is equal to, you can do the calculation yourself. Okay, so 2 square 4 into pi, 4 pi will sustain. 10 to the power minus 4, okay, minus 2 whole square minus 4 into 10 to the power 8 is 10 to the power 4. So this is the correct answer. 4 pi into 10 to the power 4 Newtons. Option B is the correct answer. Alright, so it's a very simple question. It is just simply testing the knowledge of stress. So stress is nothing but load by area per unit area, force acting on it per unit area restoring force. Okay, they both are the same, like if you think interchangeably. All right, so applying all the values, you will get the answer. All right, very simple, very straightforward. Now let me just remind you once again about the Lakshya KCET crash course program. So it is specially curated for the KCET examination, which is imminent in the month of April, and this is a particularly 28 days program. So it is curated just for those people who are dreaming for the best ranks, best scores, and to get into one of the most privileged colleges in the state. All right, so once again, for all the details and updates, please don't forget to join our WhatsApp channel. Quickly join our WhatsApp channel. The link is given in the description box. All right, fine. So good luck with that. And next question. So a ring of radius 0.5 meters and mass 10 kg is rotating about its diameter with an angular velocity of 20 radian per second. Its rotational kinetic energy is, once again, very straightforward question. So first three questions are very simple, straightforward. So how do you find the rotational kinetic energy? So the expression stands like this: half I omega square, just like the rotational analog of the linear portion. So the linear kinetic velocity is half mv square. So here we substitute with all the rotational analog moment of inertia, angular velocity, and substitute for them. So the moment of inertia for a ring passing through the diameter, not through the axis of the ring, passing through the diameter, is half mr square into omega square. Now substitute all the values. So it is 1 by 4, half into half. Mass is 10 kgs and radius is 0.5 square. Okay, into omega square, and omega is 20 square. So ultimately you will get the final answer as 250 joules, option D. Okay, so you can calculate this. It's a very simple calculation. Okay, you can do it yourself. I have directly found the answer. So if at all you have any contradiction regarding the answer, okay, whether it is 250 or you're getting something else, please let me know in the comment section. Let's have a productive discussion over there as well. All right, so I really believe if you calculate, you will get 250 joules nevertheless. Okay. Yes, so this again is a very simple, straightforward question. Okay, no doubts at all. Just kinetic energy formula, all the substitute values substituted. And yes, one thing I would like to remind you is you will have to kind of remember key moment of inertia expressions of certain regular objects like ring, discs, and a cylinder, and as well as a rod, and also a sphere. Okay, so if you know one of them, then you might crack for the others as well. Like if you know through one axis, then the other axis becomes easy. All right, but please keep in mind all these things. All right, let's look at the next question. A 20 centimeter long capillary tube is dipped in water. The water rises up to 8 centimeter if the entire arrangement is put in a freely falling elevator. The length of the water column in the capillary tube will be. Now this is a direct question. First of all, it's a free falling elevator. So in the free falling elevator, the net acceleration, okay, the felt effective acceleration is g minus a. So the acceleration of the free falling is also g minus g. The net acceleration of a free falling, net acceleration will be, net acceleration or effective acceleration will be 0. Okay, effective acceleration. Better than net, I think you can take over effective acceleration. Effective acceleration will be 0. So since the effective acceleration is 0, okay, weight experienced will be 0 for any object, the capillary tube will be entirely filled. Okay, the capillary tube will be entirely filled, and the correct answer here is actually 20 centimeter. Okay, so the entire this thing will be filled. So there won't be even a single this thing left. So entirely it will be filled. So the correct answer over here is C. And now why is it entirely filled? Because of the net acceleration. So free falling means effective acceleration becomes 0 and the total tube will be filled. All right. Once again, this is a straightforward question. Yes, you have to have the idea of the net acceleration. Okay, when anything is in lift, what will be the effective acceleration? It is g minus a when it is going down, g plus a when it is going up. In free fall, g minus a, the a part will be g itself, g minus the 0, effective acceleration will be 0. All right, fine. Look at the next question. The temperature of a rod increases from T to delta T. There's an increase of delta T. Its moment of inertia increases from I to delta I. So there's an increase in delta I. If alpha be the coefficient of linear expansion, then what is the value of delta I by I? Now this is slightly tricky question. Okay, I would place this question somewhere at the mediocre level of difficulty, medium level difficulty. So what is key here is you have to take something known to something that is unknown. Okay, so there are a huge gap. Temperature and moment of inertia is not something that is directly related, or we have related it before. So we need something that is relatable, that is a length. Okay, so how is moment of inertia related to length for a particular rod? So we can write for a rod I is equal to, okay, for a rod I is equal to 1 by 12 ml square. Okay, at the edge, right? So when it is rotating about the axis, passing perpendicular to its length, just touching the edge, okay, one end, it is this. Now again, a rate of change. Okay, so how will the moment of inertia change with respect to length? Now this also we have seen. So you can multiply the power into rate of change of length. All right, so this is very simple, all of you know this. Now is where you have to bring the coefficient of linear expansion and temperature. So according to coefficient of linear expansion, delta L by L is equal to alpha into delta T, change in the temperature. This is the crucial part in this question. Okay, so you need to take this portion and you need to take this portion. So you need to take something known to find the unknown. So this is all known to you. Okay, so now take this substitute over here, you will get 2 alpha delta T. So the correct answer over here is option A. So what is the rate of change of moment of inertia delta I by I? That is 2 alpha delta T. This is how it will vary with respect to temperature. Alright. So this is a very important question. Please mark this question. This is a very unique question as well. Okay. This will really give you an insight how questions can be asked. Okay. So they can ask you to relate something that is known to something that is unknown. I mean the relation which is already unknown. So you will have to get this relation. Alright. Very nice question. Let's look at the next question. The pressure is P, volume V and temperature T of a gas in a jar A, and the other gas in the jar B is at pressure P, volume V by 4 and temperature 2T. Okay. Then the ratio of the number of molecules in jar A to jar B will be. Obviously, you have to take the ideal gas equation. Okay, ideal gas equation is the perfect recipe for this, but number of molecules. Now, how do you bring number of molecules in the ideal gas equation? So that is brought upon by the formula PV is equal to number of molecules into Boltzmann constant into T. Okay, so this is the starting point. Now we can apply it for both the jars. PA VA is equal to NA. Okay, so this is the Boltzmann constant. Let me just write that K because T will just confuse TA, and PB VB is equal to NB K into TB. Divide both of them, you will get NATA by NBTB is equal to PAVA divided by PBVB. Just cross multiply T, so we will ultimately get the ratio of number, that is NA by NB is equal to PA VA TB divided by PB VB TA. Now substitute all the values. So in jar A it is P, V and T. Okay, so jar A it is T, and in jar B it is P, V by 4, okay, and 2T. Just cancel out all the common terms, TT, V cancels, 4 goes up, 8:1. So the correct answer is option D, 8:1. So this question is slightly tricky, so you need to, once again, is a mediocre level question. So you need to know this particular formula, the relation gas, ideal gas equation with number of molecules. In that case, you can actually proceed from here to here. All right. So this is very, very important question. Once again, they are asking you to connect multiple concepts. Very important question. All right, students, please mark this question and please take down this solution. It's very, very important. So not very easy, because you need to know this thing and how to connect it. Then you will be able to do it. All right. Yes. So these kind of questions are those challenges which will really enable you to kind of focus into what is required and get through. All right. Next question. Let's see. So 2 moles of helium gas, gamma 5/3, are initially at temperature 27 degrees Celsius and occupy a volume of 20 liters. The gas is first expanded at constant pressure. Until the volume is doubled. Then it undergoes an adiabatic change until the temperature returns to the initial value. What is the final volume? Now, this is a lengthy question, and therefore, just because of the length and multiple concepts that is involved, it is a difficult question. Okay, let me characterize this explicitly as a difficult question. Now let us pass through this chronology one by one. First, we are given a gas, okay, helium gas. Of course, gamma value is given 5/3, and initially at temperature 27 degrees Celsius and occupy volume of 20 liters. All that is given, but pressure is not given. Okay, let's analyze. So first thing that we notice here is pressure is not given. Now, how do we find pressure? Of course, yes, ideal gas equation. So using the ideal gas equation, I can write P is equal to nRT divided by V. PV is equal to nRT, so P I can write it as nRT by V. Correct. And this is the first condition, so let me write as P1. Okay. And now substitute all the values. It's just 2 moles. R is equal to 8.31. Okay. Temperature, of course, in Kelvin it is 300. 27 degrees Celsius is 300 Kelvin. Whole divided by volume is 20 liters. Okay. So 20 liters is the volume. So 20 liters, when you convert it to meter cube SI unit, it is 10 to the power minus 3, of course. And ultimately this will come around a value. You can do the calculation. Okay. You can do the calculation. Ultimately end value will get around 2.5 into 10 to the power 5 Newton per meter square, Pascal. Okay. SI unit, you can maintain Newton per meter or Pascal, whatever. Fine. Now you have got the pressure. Now at this constant pressure, what can you find out? The constant pressure, since the pressure we have found out, the first one. Now maintaining the constant pressure, volume is changed. How? See. So then the gas is first expanded at a constant pressure until the volume is doubled. At constant pressure, when you expand the volume, which other quantity will change? Obviously, temperature will change. So at constant pressure, okay, at a constant pressure, V1 by V2 is equal to T1 by T2, right? So when you apply the values, V1 is 20, V2 is 40, okay, double, expanded to double, V2 is 40, and then you will get it as T1, that is the first one, that is 300 by T2. Okay, so T2 is obviously, we all know T2 is given as 600 Kelvin. Okay, T2 is 600 Kelvin, fine. So now we have found the T2 as well. Now ultimately we have to find, then it undergoes an adiabatic change until the temperature returns to the initial value. What is the final volume of the gas? Okay, what is the final volume of the gas? Now since adiabatic condition has come into the picture, we have to assume gamma is equal to, and what is the adiabatic formula? Adiabatic equation is given as T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. Okay, T1 V1 minus T2 V2 gamma minus 1. So now T1 V1 and T2 V2. So we have to find out, then it undergoes a volume change until, so we have to find the V2. Okay, so V1 we know, and T1 T2 also we know. So what is the final one? So it returns back to the original temperature. So T2 finally it goes back to original 300 Kelvin, and now it was 600. Volume is around 40 into 5 by 3 minus 1 is 2 by 3. Okay, so we all know gamma minus 1 is 5 by 3 minus 1, which is 1 by 3. Okay, sorry, 2 by 3 into V2 power 2 by 3. Now you just have to solve for V2. So all of you can solve for V2. Take the power 3 by 2 on both the sides. Okay, take the power 3 by 2 on both the sides. So this power will get cancelled. This power will get cancelled. 600, 300, it's already 2. 2 power 3 by 2 into 40. So ultimately you will get V2 value is approximately as 113.3 liters. Okay, 113.3 liters, that is option A. So pressure was actually not needed at this point, but still anyway, so let it be, pressure was not needed. So we could have anyway found out the final volume using all the given conditions. So you can actually start considering from this point. All right, yes, yeah. So first find at constant pressure what is the final temperature. T2 is equal to 600, we found out that, and from there when it goes back to its original temperature 300, so what is the final volume? That is 113.3 liters. All right, so this is how you do it. This is a difficult question. Okay, this is definitely not an easy or mediocre level question. This is a difficult level question. So all of you please heed this question carefully, and also let me just remind you, this kind of question is highly unlikely in CET because of the sheer amount of time it consumes and the difficulty level being very, very high. Okay, so that kind of questions not usually asked in CET, but in case if it comes, please be ready. Okay, thermodynamics and kinetic theory is a very important chapter. There's a lot of tricky questions possible from that chapter, so please revise those chapters very, very carefully. All right, fine. So since after clearing a difficult question, let's go to the next question. It's a very simple question. Two equations of two simple harmonic motion, A sin omega t minus alpha and B cos omega t minus alpha. Okay, so we have two things. What is the phase difference between the two? First of all, let me clear you. You would have noticed the amplitude is different. Amplitude has nothing to do with the phase difference. Okay, so don't worry about the amplitude. Just look at what is inside the sine and cos. Look at the argument. Okay, so now the first thing here is one is sine, one is cos. Try to make it into a single function. Make either both of them cos or both of them sine. Let's take x is equal to A sine omega t minus alpha. This can also be written as using the trigonometric identity cos pi by 2 minus, or since it is cos, we can take omega t minus alpha also. There is nothing wrong in that. Okay, it's actually pi by 2 minus omega 2 minus alpha, but you can interchange because it's cos. So see, cos pi by 2 minus omega t minus alpha. Okay, this is also equal to cos omega t minus alpha minus pi by 2. There is nothing wrong. Why? Because cos of x is equal to minus x is equal to cos of x. Okay, so you can take that, no problem. All right, fine. Now let us come to y. Y is equal to b cos omega t minus alpha. What is the difference in the phase angle both of the places? Here it is minus pi by 2, here there is nothing. So the difference in the phase angle is pi by 2. The difference in these both is pi by 2. So the correct answer is option C. The difference in the phase angle is pi by 2, which is equal to 90 degrees. All right. Yes, so this gives you a very important result. What is it? So whenever you have this kind of a scenario where you have two simple harmonic motions where everything is same, okay, amplitude let it out of the equation, where your argument is same but the function is sine and cos, so definitely it is 90 degree, phase difference is 90 degree. Okay, this is a very, very important result. So you will have to learn all these tips. This is one of the tips. Okay, when it is sine and cos, same argument, and don't worry about the amplitude, the phase difference will be 90 degree. When will it be 180 degree? Just looking at the equation you can say. Okay, so all these tips are very, very important from the oscillations chapter. Always a very simple question. Look at the next question. The ratio of the fundamental frequency of an organ pipe opened at both ends and that of the organ pipe closed at one end. So here the fundamental modes of open and closed pipe is very important. So you need to know that. So it is actually for a closed, for first let's say open. So the fundamental node for an open pipe is V by 2L, and for a closed pipe is V by 4L. So when you take the ratio, so open pipe fundamental node by the closed pipe, so V by L will get cancelled, okay. V by 2L by V by 4L. So obviously L and V will get cancelled. 4 will go up, 2 will come down. It is 2:1. The correct answer is option C. Very simple question. Very simple question. So if you know the fundamental modes, then definitely you can write and you can find the answer. Alright. It's very as simple as that. Okay. Yes. So this is the fundamental. Okay. Fine. Now let us see the next question, which is 130th. Okay, so 130th. The charges on two spheres are +7 and +5. So they experience the force F if each of them is given additional -2. So what will be the new force of attraction? What will be the new force of attraction? Now, given the question, if you do this, so what will happen is very simple. So this will be, see, there is a slight error in the question as well as given in the solution. So there might be slight mismatch. If you have done exactly like this, so you will get initially, the initial force will be very simple, K into 7 into 5 whole divided by some distance, okay, some distance r square. So this is 35 K into 10 to the power minus 12, of course, don't forget that it's micro, into r square. Okay, now the new force when -2 is added to both of them, 7 minus 2 will become 5, 5 minus 2 will be 3, so 5 into 3 15, so 15 is actually 2 times root 3 times, so nothing matches. Okay, actually there is an error in the question according to the given options. Okay, so the question should have actually been -5. Question should have actually been -5. So I make this correction according to the options given. So multiple, okay, the method is same. Anyway, you are going to add -2 both the sides. Okay, so whatever you get, it would be 15. Okay, if you add -2 in the present condition, +7 and +5, if you do -2, it will be +5 and +3, 15. That's not relatable actually here. So just to match this, I am telling you method is all the same. It will be K into 7 minus 2 into -5 minus 2 divided by r square. Okay, in this case what will happen, K into this will be 5 into -7 divided by, okay, anyway 10 to the power minus 12 whole divided by r square. So this is once again minus 35 K 10 to the power minus 12 divided by r square. So they both are actually same, magnitude wise they both are actually same. Once if you consider this as -5, not +5, as -5. So you need to consider this as -5. In that case, this will end up as both the forces being equal. Okay, so magnitude of F is equal to magnitude of F dash. Okay, so this will ultimately be option A, F. The force of attraction will be F itself. Okay, so that's what I was trying to say. According to the result or the solution given, it should have been -5. Now if you would have attempted +5, then you should get F dash as 15, right? +7 minus 2 +5, +5 minus 2 +3. So 7 in 5 into 3, 15. So you should have got 15 K square 10 to the power minus 12, all that. Okay, so this is how you get it. All right, very simple, very simple. The only thing you have to vary, because you are varying the charge, vary the charge, the product, and ultimately you'll get the answer. All right, very simple question once again. Yes, next. A charge Q is enclosed by a Gaussian spherical surface of radius r. If the radius is doubled, then the outward flux will. This is a very repeated question. This is a very important question also. This kind of tests your understanding of Gauss law. What does Gauss law say? The total flux coming out of a closed surface is 1 by epsilon naught times the charge enclosed. So this never ever specifies anywhere the variation of size of the closed object. It only depends on the charge enclosed. So let the size be double, triple, small or whatever, as long as it encloses the charge, as long as the charge is inside the Gaussian surface, the flux is always going to remain change. Okay, as long as the charge is fixed and inside the Gaussian surface. If the charge changes, yes, flux will change. But if the charge is fixed, it will not change with the size. Okay, so very important, very simple question, very repeated question, but it tests the knowledge or understanding of Gauss law. Okay, yes, that's why this is a very repeated question. Next, 4 charges Q1 2 in 10 to the power minus 8 and Q2 Q3 are all placed with 4 corners of a square. Okay, yes, so 4 charges, what are all they? They are all like one is 2 into 10 to the power minus 8, the other is minus 2 into 10 to the power minus 8, and minus 3 into 10 to the power minus 8, all coulomb, 6 into 10 to the power minus 8. What is the place at 4 corners? Root 2 is the side distance is root 2 meters. What is the potential at the center? At the center means at the midpoint of the diagonals. Now just imagine a square having a side root 2. Okay, root 2. What will be the diagonal length? Diagonal length will be simple, very simple. Diagonal will be whole root over root 2 square plus root 2 square. How much is that? 2 plus 2, 4. 4 root is 2. So the diagonal is 2. Therefore, this distance is 1. Okay, this distance is 1 meter. Now you can write the total potential at the center. Total potential at the center, VO is equal to K is common. K is common and distance is common. R is common. Only change is in the charges. So 2 and 10 to the power 8 is common into 10 to the power 8 minus 8. I'm sorry. Minus 8. 2 minus 2 plus minus 2 plus minus 3 plus 6. So 2 and 2 gone and minus 3 plus 6 is 3. So 3 into 10 to the power minus 8 into K. What is K value? 9 into 10 to the power 9. So the correct answer is 270. Okay, very simple. This is, as you see, you can understand the correct answer is 270. Okay, so no doubt on that. 270 volt is the correct answer. Very simple question, but yes, you will have to imagine and you will have to try to decipher this particular thing. That is, when you have 4 charges spread over the corners of the square and the side length is root 2, what is the diagonal and what is the distance which you have to consider for the voltage formula? Yeah, you will have to have multiple things in mind and then you will be able to do it without any problem. All right. It's a good question, really good question. Please mark it as an important question. Next question. A pendulum, okay, a pendulum bob of mass 30.7 in 10 to the power minus 6 kg carrying a charge 2 into 10 to the power minus 8 coulomb is at rest in a horizontal uniform electric field. Okay, so it is hanging. So you have a ceiling, this is the vertical, and it is hanging like this. All right, it's hanging like this. So you have a tension in this direction which you have to find out. Okay, and there is some angle. Obviously there would be some angle. Okay, so it is hanging like this because of a electric field, a coulombic force, and then it has obviously a weight. So applying the components of the tension, okay, applying the components of the tension, hold on. Yes, applying the components of the tension, we can write that obviously T cos theta is mg. T cos theta is equal to mg, okay, and T sin theta, the perpendicular component, T sin theta is equal to QE. Okay, so these are the components which you already know, but the problem here is we don't know theta. Theta is not given in the question. Then how shall we solve it? So if theta is not known, let's take the advantage of the property of sin theta and cos theta. There is a trigonometric identity. When you add square and add both of them, t square sin square theta plus t square cos square theta is equal to mg square plus QE whole square. Okay, mg square plus QE whole square. So sin square theta cos square theta is gone. Okay, so now you have t is equal to, take square root both the sides, mg square plus QE square. Okay, now what is mg? mg is equal to, mass is 30.7 in 10 to the power minus 6 into 9.8. Okay, 30.7 into 10 to the power minus 6 into 9.8 whole square plus QE, that is 2 into 10 to the power minus 8 into 20,000. Okay, whole square. Now you take the root. So you can try to find this. Okay, you can try to find this. We have already done. This is root of 3 square, 3 into 10 to the power minus 4 whole square plus 4 into 10 to the power minus 4 whole square. Okay, so you can check it yourself. Okay, you can cross check it, and if there is any contradiction, please let me know. It is 3 square. This is 3 square, 3 into 10 to the power minus 4 whole square plus 4 into 10 to the power minus 4. This will ultimately come to Pythagorean triplet, being Pythagorean triplet, 5 into 10 to the power minus 4. Option C is the correct answer. Alright. So this question is not very easy. It is slightly tricky, not very difficult as well. So you need to have an understanding of components and how to solve the components if the theta value is unknown, all that. Okay. So if you have that idea, you can very simply do this. Okay. So ultimately you will get the answer as 5 into 10 to the power minus 4 Newton is the correct answer. Alright. Yes. So this is the tension. Alright. So this is, once again, please mark this question for the method which we have used here. This is a very unique method which you can employ whenever you don't know the theta value. Okay, so if you know the if you know the vertical and horizontal component, ultimately you will get the answer. Alright, fine. Now let's see the next question, that is 134. The electric potential at a point xyz is given by V is equal to minus x square y minus xz cube plus 4. Okay, the electric field E. So the vector at the point is, what is the vector? Electric field vector. Okay, now I don't know how many of you, most of you might be aware of the formula, that is E is equal to minus del V divided by del R. Okay, del V divided by del R. Now what is this del V by del R mean actually? It's actually a function, okay, mathematical function, which implies minus del V by del X, okay, partial differentiation over X for I cap, minus del V by del Y, partial differentiation of Y for J cap, minus del V by del Z for K cap. Okay, so you have to partially differentiate with each particular. Partial differentiation means you differentiate only that particular variable. For example, in the entire function, just differentiate only x. So what will you get? Minus 2x, okay, minus of minus 2x y, this is minus 2x y, and if you differentiate here, you will get minus z cube. This is I cap minus, now differentiate only y. So this you won't get anything. Here only one y component is there. If you differentiate, you will get minus x square j cap minus, and ultimately differentiate with respect to z. So you will have minus 3z square x k cap. So ultimately what is the correct answer? Minus will cancel everywhere. So it is 2x plus z, 2xy plus z I cap, yes, and plus x square j cap plus 3z square k cap. So the correct answer is option D. Okay, so the correct answer is option D. Now this, if you didn't know this method, how this came into this is how you define this particular del V by del R. Okay, so this is a mathematical function. So del V by del R can be expanded like this, del V by del X. Okay, so not del, it's actually dou V by dou R and dou V by dou X. Okay, the del is the function, sorry, just reiterating, del is the function. So dou v by dou r and dou v by dou x, and you will get like this. All right, fine. So just partially differentiate each variable of the function, total function, and you will get the answer. All right, fine. Now let us look at the next question. Okay, now consider a parallel plate capacitor of 10 microfarad with air filled in the gap between. Now one half of the portion, that means this is half of the portion. Now let me use a dark color. This is half of the area, and this is the remaining, that is a by 4, and this is once again a by 4. Okay, a by 4, a by 4, a by 2. All right, so this is the spread, how it happens. Fine. Okay, so now this is air. Actually there is no dielectric, this is air, this is air. Now whenever you have this kind of a combination of dielectrics, it's a parallel combination. Okay, it's a parallel combination where it is covering the entire distance. Each of the dielectric is covering the entire distance. It's like 3 capacitors which are in parallel. It is like 3 capacitors which are in parallel. 2 air capacitors and 1 dielectric capacitor, they are in parallel. So how would you find C equivalent in case of parallel? C1 plus C2 plus C3. So we have 2 airs, so C1 and C2. For air, how do you write it? Epsilon naught A by D. Okay, here A is 4, A by 4 plus epsilon naught A by 4 by D plus, with this dielectric we have K epsilon naught A by 2 whole divided by D. Now what are all common? Let's pull it out. So we have epsilon naught A and D common. Let's take it out. Epsilon naught A whole divided by D. And what are all remaining? It is 1 by 4 plus 1 by 4 plus K by 2. So when you solve all this, you will get epsilon naught A by D is given, that is 10 microfarad. This is the normal capacitance, epsilon naught A by D. So we have 10 microfarad into K by 2 plus 1 by 2, that is K plus 1 by 2. So K is equal to 4. So 10 into 4 plus 1 by 2. This is 5. 5 into 5, 25 microfarad. So the correct answer is ultimately option A, 25 microfarad. So how did it come? So this kind of a setup I am reminding you, where the dielectric takes the multiple dielectrics, take the entire distance between both of them singularly. Okay, just this has taken entire distance, air has taken. So it's kind of a parallel connection, 1, 2, 3. And in parallel connection, how do you do total? Like this, individual sum, like you do for resistance in series, right? So when you do like that, you can take the common things outside and remaining things calculate, and ultimately you will get 25. Once again, if you have any contradiction from the calculation that you have done from your end, so please let me know in the comment section, okay, so that we can have further discussion on this, right? Okay. This also is not a very easy question, not a very difficult question. Somewhere we can place in the mediocre difficulty. Okay. The thing is that if you miss even a single step somewhere in between, the final answer will falter. Alright, so fine, let's look at the next question. 3 infinitely long charge sheets are placed as shown in the figure. So these are the infinitely long sheets. Okay, this is 1, this is 2, and this is 3. Alright, 1, 2, 3. Fine. So now the question is, the electric field at point P is. So what is the electric field at a point P? So this is the sheets 1 and 2 and 3. So at a point P here, exactly at the center, what is the electric field? Now first of all, you have to see the net electric field. There are 3 plates. So what is the net electric field direction? Now because of the first plate, it's the positively charged, because it's the charge density is positive, it will have electric field towards this direction. Alright, this is E1, and since 2 and 3 are negatively charged, they will have an electric field pulling towards them. So this is E2 and E3. So all of them are in the same direction and they are in the negative Z direction. So electric field, ultimately when you write the net electric field, is first of all in the negative Z direction. Okay, negative Z direction. So we can cancel all the positive Z direction options, that is option A and B. They all have positive, they are pointing towards the positive Z direction, that is K. So we can eliminate that. So the only possible answer is either C or D. Now we have to find out the magnitude. So what is the magnitude? So since we are given with the infinitely long sheets, so we know that the distance is not a parameter for the electric field of infinitely large sheets. So the electric field is actually, the magnitude of electric field can be found out by the addition of electric field of each of the plates. For example, for the first plate we have sigma by 2 epsilon naught minus 2 sigma by epsilon naught, okay, and minus sigma by epsilon naught. All right, so when you calculate all of this, ultimately you will get 1 second. So each of them you are adding the magnitude, right? So you can just add the magnitude. Magnitude wise, you needn't worry about the sign, okay, because sign anyway is somewhat we have taken care of in the direction itself, okay. The negativity has been taken care of in the direction. So let's just leave it in the magnitude side. Magnitude, just look at the numbers. So when we add all of them, numerator we have 4 sigma divided by denominator we have common 2 epsilon naught. So which is 2 sigma by epsilon naught, okay. So the net magnitude wise, the net is 2 sigma by epsilon naught. All right. So the final answer over here is net electric field at point P is given as magnitude 2 sigma by epsilon naught into minus k. Okay, so the direction is minus k, so we have minus k cap. Option C is the correct answer. All right. So this is actually a repeated question. This has been there in one of the previous CETs, previous year CETs. So this is a repeated question. Once again, yes, this is definitely an important question. All right. No doubt it's an important question. These kind of questions can be asked again. So please mark this question as an important question and try to solve such problems. Okay, multiple sheets, you have multiple spheres. These are all very repeated questions, very, very important. Multiple spheres, so what will have the net electric field at a particular point, net potential at a particular point. These are all very important questions. Please focus more on this. All right. So this is how you do it. First, we will affix the direction of the net electric field. Then find the magnitude. You will easily get the answer. All right, fine. So let us look at the next question, shall we? Yes. The electric field intensity just sufficient to balance the Earth's gravitational attraction on an electron will be very, very simple. So it's like one of the electrons is balanced by the electric field against the gravitational force. So electron is supposed to fall or go attract towards a larger body due to the force of gravitation, but instead, especially Earth, instead it is being balanced by an electric field. Okay. So finally you can write the equilibrium condition. So two forces are balanced, equal and opposite. So those two forces are the electrostatic Coulombic force and the gravitational force. So let's write all the values. 1.6 into 10 to the power minus 19, and the electric field is given as, okay. So you don't know the electric field we have to find out. Mass of the electron is given as 9.1 into 10 to the power minus 31, and charge is given as 1.6 into 10 to the power minus 19. So just calculate and ultimately you will get the answer as minus 5.6 into 10 to the power minus 11 Newton per Coulomb. Okay, so you can do the calculation yourself and cross check. Once again, let me remind, if you have any contradiction like in the calculation that you found, this I have written directly. So if you have any contradiction in the calculation, please let me know in the comment section. All right. So this is how you get this answer. Once again, this question is not a very difficult question. It's actually a very simple question. You can easily do it. It's direct formula based. Such equilibrium questions are very, very simple. Most of the values will be given. You just have to find one unknown value. All right, just like here. Fine. So that is the answer. Now let us look at the next question. The next question is, okay. So 5 conductors are meeting at a point X as shown in the figure. What is the value of the current in the 5th conductor? So what is the current in this conductor? Okay. All right. What is the current in this conductor? So basically, as we all know, Kirchhoff's junction rule is applied over here. So the sum of all the currents entering is equal to sum of all currents exiting. So all currents entering, we can write it as 5 plus 4 is equal to exiting is once again 5 plus 3 plus, let this be X, okay, or I. So I, So 5 gone, 4 minus 3, 1. I is equal to actually 1 ampere. And it is exiting. Okay, so that's how you match it. So it's exiting finally. So 5 plus 1 plus 3 is equal to 5 plus 4. So it is exiting. So it is 1 ampere away from X. Option B is the correct answer. Okay, option B is the correct answer. Alright, so once again, very, very simple problem, very easily solvable, right? Look at the next problem. An electric current passes through a circuit containing two wires of the same material connected in parallel. If the lengths of the wires are in the ratio 4/3 and the radius of the wires are in the ratio 2/3, then the ratio of the current passing through the wires will be. So first of all, we have to find the ratio of the resistance. Then we can take an inverse reciprocal, that is the ratio of the current, right? Like all of you know this, right? So current is inversely proportional to resistance, which implies I1 by I2 is equal to R1 by R2. Sorry, R2 by R1. Okay, R2 by R1. Now let us see R1 and R2. So the resistance is actually proportional to length and inversely proportional to square of the radius. Inversely proportional to area, so we can take square of the radius. Right. Now let us establish a ratio here. R1 by R2 is equal to, since length is directly proportional, I can write L1 by L2. And R square is inversely proportional, so I'll write R2 square by R1 square. Alright, L1 by L2 is nothing but 4/3. Okay, length of the wire ratio is 4/3 into ratio of the radius square. So 2 square and 4 will get cancelled, okay, and 3 and 3 square will get cancelled. So the final answer is 3:1. Alright, so R1 by R2 is 3:1. Therefore, I1 by I2 is equal to R2 by R1. Reciprocal 1:3. So the correct answer is option B. Alright, so the correct answer over here is option B, 1:3. So whatever is the resistance ratio, the reciprocal of that will be the current ratio. Okay, so that is very, very simple. All of you can understand. So more the resistance, less will be the current. Very easy question, so there is nothing much to worry about this question. But yes, you need to have a very good flow and don't squander at any point, because even if you make a tiniest mistake, that will lead to the wrong answer. All right, all are very confusing options. It's very easy to kind of get away from this. In fact, 3/9 is also correct, okay, logically if you say, but ultimately you get 1/3, so more precision wise you go with that. So this option you should have removed, but still it's okay anyway, doesn't matter. All right, fine. Now next question, let's see. When the current I is flowing through a conductor, the drift velocity is V. If 2I flows through the same metal but having double the area of cross section, then the drift velocity will be. See, first of all, we need to understand what is the drift velocity formula. The drift velocity formula is given as, with respect to current, is given as I divided by NEA. Okay, this is the drift velocity formula. Suppose this is the actual drift velocity, suppose. And now the drift velocity, we want to find the new drift velocity. Okay, dash. So we have a new current, 2I. Then nothing else is changing, same material, same metal. So NE is same. Now the area is also becoming double. Okay, so let's write 2A. But ultimately when you cancel out the similar terms, it turns out to be the new drift velocity is just the same as the old drift velocity. So the correct answer is option C, V itself. Both current and area, when they change simultaneously, the drift velocity will remain constant. Okay, very simple. Only if you know this particular formula, you can do it very easily. Very, very simple question. Okay, yes, so we have had a stream of simple questions right now for a while. Let's see the next question. All right, a small power station supplies electricity to 5,000 bulbs connected in parallel. So all the 5,000 bulbs are connected in parallel. Each bulb has resistance 200 ohms and is operated at 220 voltage. The total current supplied is, another very simple question. Each bulb has 220 volt, and since they are all connected in parallel, all of them will have same potential. So the current is actually found for each of them. Okay, for each of them is V by R. Okay, resistance of each of them 220 by 220. It is 1 ampere for each bulb. A single bulb will get 1 ampere. So you can just guess how much will 5,000 bulbs connected in parallel will get. So all of them will get 1, 1, 1, 1, 1. Total will be 5000 ampere. 5000 bulbs will have 5000 ampere. Each bulb will have 1 ampere. So 5000 bulbs will have 5000 amperes, right? Very simple, logical. You all can do this very well. Just you need to have a right presence of mind, understand each bulb, each resistance, and voltage is also same because of parallel connection. So find the current and then total current. Okay, very simple, right? Next question, let's see. A cell having an EMF epsilon and internal resistance R is connected across a variable external resistance R. As the resistance R is increased, the potential, the plot of potential difference V across R is given by. See, the basic question where you can apply the Ohm's law. Okay, so Ohm's law suggests that the V is proportional to I, so V is equal to IR, right? V is equal to IR. Now see the variation of voltage and resistance V and R. So they are directly proportional. So voltage increases with resistance. It's not the other way around. Voltage does not decrease with resistance. Voltage drop across the resistance will increase with the increase in value of resistance. That itself allows you to tell that A and B are wrong because they are decreasing. Voltage is decreasing with resistance, not possible. Voltage must increase with resistance. Now we have two possibilities, C and D. Alright, but now the problem is that the resistance is connected to an EMF. Now according to Kirchhoff's voltage rule, the algebraic sum of the voltage in a particular loop in a given circuit, simple circuit, is 0. That means whatever EMF is applied by the battery, that much only the resistance will have. Resistance will not have more than that, right? That even contradicts the conservation of energy as well. So where does that extra potential coming from? Correct. So the potential across the resistance cannot be more than the EMF. So it cannot go unlimited like this. Okay, like option D. It has to stop at a particular point, which is the EMF. So the V will have minimum value 0 when R is equal to 0. And we will have a maximum value EMF even if R goes towards infinity. Even if R becomes an extremely large value, our voltage will get exactly halted at this particular point. Alright, voltage will be EMF to the, equal to the EMF itself. So it's a very, very important point. Alright, so please keep it in mind. Yes. Alright, so very, very simple question. You just need to have, again, right presence of mind. Presence of mind is extremely important. You need to decipher the question and which topic it belongs to. How do you approach the question depending on the topic, all are very, very important. All right, fine. Let us look at the next question, shall we? So the next question is given as the resistance of a bulb filament is 100 ohms at a temperature 100 degrees Celsius. If it is temperature coefficient to be 0.005 per degree Celsius, its resistance will become 200 ohms at the temperature of. So at 100 degrees Celsius, we have 100 ohms. At 200 ohms, what is the temperature? Very simple. Once again, this is the same format we use, that is R1 by R2 is equal to 1 plus alpha T1 by T2. 1 plus alpha T2. Okay, so this is 200 divided by 100 is equal to 1 plus alpha T. We don't know the T value at 200 ohms. 1 plus alpha 100 degrees Celsius. Substitute all the values, substitute alpha value, and then just cross multiply, cancel these two zeros, and ultimately you will arrive at a final value. Temperature is equal to 400 degrees Celsius as the correct answer, option B. Alright, so please do the calculation yourself, just simplify this. Okay, ultimately you will end up at the answer at 400 degrees Celsius. Okay, if at all there is any contradiction, please let me know in the comment section. Alright, fine. Let us look at the next question, shall we? Next question is, an electron enters a region where magnetic field B and electric field E are mutually perpendicular. Magnetic field and electric field are mutually perpendicular. Then what will happen? Then what is the consequence? Alright, it will always move in the direction of magnetic field B. It will always move in the direction of electric field E. It always possesses circular motion. It can go undeflected also. Now analyze each of the situations, you will understand. it will always move in the direction of magnetic field. No, that's not correct. Okay, because there's an electric field perpendicular to it. Electric field can pull it up, right? It will always move in the direction of electric field. No, need not, because still magnetic field is perpendicular there. That will have an effect. It can always possess circular motion. No, no need. That is only when there is a magnetic field. When there is an electric field, there will be distorted motion, if at all. Then the only possibility remaining is it can go undeflected. Okay, so when electric field and magnetic field are perpendicular to each other, so the only possibility remaining for the electron or the charged particle to move through is moving undeflected, with the net force acting on it being 0. Alright, so that is the primary possibility here, and that is the correct answer. Rest all are impossible. Okay, always it's ascertaining something, it's imposing something which is not possible, right? Once again, an easy question. Let's look at the next question. Magnetic field intensity at the center of a coil of 50 turns, radius 0.5, and carrying current 2 is very simple here. Magnetic field at the center of a circular coil is given as n mu naught I divided by 2r. Right, where n is 50 and mu naught is, we all know, 4 pi into 10 to the power minus 7 into I is 2 whole divided by 0.5. So when you calculate all this one by one, you will get the ultimate answer as option B, that is 1.25 into 10 to the power minus 4 Tesla. Okay, option B is the correct answer. Once again, so I have just jumped through the calculations, which you can do it obviously by yourself as well. Just have a clear understanding of all this, substitute the values clearly, and then you will get the answer. All right, once again, if you find any contradiction, please let me know through the comment section. All right, fine. Let us look at the next question. So the next question is given as a straight wire of length 0.5 meter and carrying a current of 1.2 ampere is placed in uniform magnetic field of induction 2 Tesla. Okay, that is magnetic field is 2 Tesla. The magnetic field is perpendicular to the length of the wire. The force in the wire is, once again, very simple direct problem. Force experienced by a straight conductor, ILB. So current into length into magnetic field. So the current is 1.2, length is 0.5, and the magnetic field is 2. So ultimately this all suffices to 6 into 2, that is yes, 3. Okay, so the correct answer over here is 1.2 newtons. Now this is not a big calculation because anyway 0.5 into 2 becomes 1. So the correct answer is 1.2 Newton. Okay, very simple question, very simple, straightforward. There's just a formula based. If you apply the formula itself, you will get it, no doubt, right? Next, two equal electric currents are flowing through perpendicular to each other in the figure. AB and CD are perpendicular to each other and symmetrically placed with respect to the current flow. So the current is flowing like this. Okay, let me just change the color. So this is the one particular current flow, I, and the other is going like this. This is also I. So the question is, where do we expect the resultant magnetic field to be 0? Which line will have resultant magnetic field 0? ABCD, both ABCD, both OD and OB. Okay, so OD and OB is like the half of these lines. All right, now you can apply the basically the right hand thumb rule and see how the fields are getting cancelled. Okay, so this is going like this, field is coming outwards, and for this field is going inside. So they both are actually getting cancelled each other midway. Okay, along the direction of their flow, they are getting cancelled each other. So along their flow, which line is in between them? That is properly A. Okay, along their flow, the only line which is coming in between them is AB. So this is the point where the magnetic field cancel each other out, and ultimately you will get the answer. The point where the line where net magnetic field is 0 is option A. Alright, very simple. Once again, very straightforward answer. Just think straight. Okay, where is the current going? How is the magnetic field cancelling out each other? Then you will get it. Alright. Yes, look at the next question. The magnetic field lines of force inside a bar magnet are very simple here. You have a bar magnet like this. Okay, so you have a bar magnet. It has north and south. Okay, this is north, this is south, and the magnetic field lines are emanating from it. like this from north to south. This is the exterior part. Okay, exteriorly it is coming like this, but internally what happens is that internally it goes a little bit inside like this. So when it comes to the interior region of the bar magnet, the magnetic field moves from south, okay, from the south towards north. So the correct answer is actually from the south pole of the magnet, inside. We're talking about inside a bar magnet, it is from the south, okay, towards north. All right, once again, very simple question. Most of you know this already, okay. So the penultimate question, 149. So A and B are two conductors, current I, same direction. X and Y are two electrons moving in the same direction. Then, see, when you have an electron moving in the same direction, we first of all, we need to know that the conventional current direction is opposite. If electron is moving like this, conventional current direction is in this direction, okay. So X and Y are moving in this direction. That means, if X and Y are moving in this direction, that means the conventional current direction is in this direction. This is the conventional current direction in the opposite side. Okay. So A and B, they are same direction. They will attract. A and B will attract. There will be attraction between A and B. But since electrons are giving an opposite conventional current, there will be a repulsion between X and Y. So the correct answer is attraction between A and B, repulsion between X and Y. All right. So the A and B will attract each other, but they will repel X and Y. That's what they ultimately mean. So the correct answer is option B. Pretty intuitive. You can definitely get it since you know the parallel conductors, which direction will give attraction, which will give repulsion, all that. All right. Fine. Next, the last question of this video. If a diamagnetic substance is brought near a north pole or south pole of a magnet, then it will be repelled by the poles, both the poles, okay, not one pole or two pole, it will be repelled by both the poles because it's a diamagnetic substance. Okay, so the field lines go around the diamagnetic substance, so it will definitely be repelled by the poles. So wherever the poles are, wherever the material is, near the poles or near any one of the pole or the other pole, the magnetic field lines definitely will move away from the diamagnetic substance, so there will be a repulsion, okay. The correct answer is option B. So such a simple question. We have had an array of simple questions towards the end, okay. So till the 150th question, especially after 137, 138, last couple of several questions like 8-9 questions were very, very simple. There will be a set of questions that are very simple, but there will be a small set of questions which are very difficult as well. All right, so that is the video part. So definitely once again reminding you all, so all the question papers of the mock test will be available in the WhatsApp channel. So all those people who hadn't joined our WhatsApp channel, quickly join the WhatsApp channel. The link is given in the description box right away. So join as soon as possible. Also the link for those people who are looking for, you know, getting away from these distractions of social media and looking to, you know, kind of just focusing on the paper and downloading it and attempting it, there is a link for you people as well on the description box itself. So there is a portal where you can register your personal email ID and the PDF format of the question will be connected to you personally. All right, fine. So that's it. And also, so I hope all of you liked our video. So please don't forget to press the like button. And there are so many people who are there in need of such genuine content. So please share our video to those people. And also don't forget to subscribe to our channel for more such content and press the bell icon so that you will get timely notification and then you will know which content is coming when. So, and don't forget to give us your valuable feedback in the comment section as well. So until the next time we meet, it's adios from Karthik. Bye bye guys. See you.